In this video, we're going to talk about the different functional groups that you find in common molecules within your bodies and within the medicines that we take. All right, so I believe we're looking at 7, could be 8. We'll see. All right, so the very first functional group we're going to look at is called alcohols. All right, so alcohols, we've kind of seen it before. It's just an OH. An OH group bound together is an alcohol group. So normally that's just bound to a carbon molecule. And an example would be something like ethanol. All right. You could also see isopropanol. So that little added extra carbon there turns ethanol into isopropanol. So you can buy isopropanol or isopropyl alcohol from the store, usually within the pharmacy section. So this is an example of a alcohol functional group. The next functional group looks like it's an alcohol, but it's not. It's a carboxylic acid. So the carboxylic acid has a carbon that's bound to an OH and double bound to an oxygen. Okay, so again, you might first say, oh, this is an alcohol functional group, but you must look to make sure that the carbon that the alcohol is bound to is not doubly bound to an oxygen molecule, because then that would make that a carboxylic acid molecule. Probably some of you, probably all of you, have eaten this carboxylic acid in your life. This is acetic acid, which is what makes up vinegar. So if you've ever had oil and vinegar or pickled anything, you have consumed acetic acid. So again, you can see that carboxylic acid functional group right here, right? All right, the next functional group we will look at is an aldehyde. So an aldehyde is slightly similar to a carboxylic acid, except for instead of an alcohol, an OH group, it is just a regular H group. Okay? Aldehydes are always found at the ends of molecules, and you could either see it as something drawn like that without the hydrogen, because remember in our bond line rules we don't show the hydrogens bound to carbons, but more times than not you will, for an aldehyde, see that hydrogen in the structure. Okay, so this is acetaldehyde. Don't really know what that's used for, but I could show you formaldehyde, which if you are familiar with preserving specimen, this is an example of formaldehyde. So again, it's only a single carbon atom with 2 hydrogens bound and that double bonded oxygen. Okay, so those are aldehydes. That's the aldehyde functional group. I get my little pink and highlight it. So it's carbon double bond to an oxygen with a hydrogen molecule bound off that carbon. Okay, so that is aldehydes. Next up, we'll look at ketones. So ketones are similar to aldehydes in that they have a carbon with a double bound oxygen, but instead of a hydrogen, they usually have another carbon coming off. So sometimes when we're talking about just general carbons, we usually depict that as the letter R. Ketones would be, an example would be acetone or 2-propanone, and this is found in nail polish remover. Okay, so again, a ketone, you look to make sure you have carbons on either side, but it's this carbon double bound oxygen with carbons on both sides. Okay. Our next functional group, let's look at the ester. Oops. The ester. So an ester functional group also kind of looks like a carboxylic acid, except for it does not have an OH, but it has this oxygen that's bound to another atom. Normally it's going to be another carbon atom. Okay, so an ester, example of what an ester would look like, could be something like that. All right, so again, our ester, we have that carbon double bound to an oxygen with another oxygen, but that it has carbons coming off of both ways, leaving that ester functional group. Another functional group to cover is the ether. So an ether is just an oxygen bridging two carbon molecules. So you could have diethyl ether, which used to be used in hospitals to kind of knock patients out. But again, so you have this oxygen that's in between two carbon atoms. I think the last functional group we're going to cover is an amide. An amide functional group has a carbon double bound to an oxygen with a nitrogen off to the side. Okay, so what that would look like shorthanded would be NH. So this is an example of an amide. So the nitrogen to a carbon double bond oxygen with two, essentially, with stuff coming off either direction. So that's an amide functional group. Okay, so we have all these functional groups. So let's look at some examples of some molecules, some common prescription or over-the-counter molecules, and see if we can find some functional groups. So if we look at Xanax first, over here, out of the list of functional groups that I gave you, I don't see anything that fits the bill. That doesn't mean that Xanax doesn't have functional groups in it, it's just not ones that we've covered. So, that just goes to show that organic chemistry gets even more complex. For example, maybe one functional group off the bat I could highlight is this right here. So that is a benzene ring. So you could say that's a benzyl group. But let's look at aspirin. Oh, aspirin has a few. I see a few in aspirin that we've covered for sure. So highlight one to start. This functional group is carboxylic acid. Remember, you have a carbon to a double bonded oxygen to an OH, an alcohol group, right? So we do have a carboxylic acid, and we have a second functional group, which is this right here, and this is an example of an ester. We talked about the ester functional group down here, correct? Ketones, esters, there it is. So here's our ester functional group. So yes, we did talk about the ester. So we have an ester and we have a carboxylic acid, carb acid. Okay, let's look at the active ingredient in Benadryl. So Benadryl, it's kind of allergy season. Maybe you guys are taking some Benadryl at night to help with those antihistamine properties. It's also called diphenylhydramine. All right, and so what do we see here? Well, kind of what we found in in the Xanax, I see two phenyl groups. So you can say these are benzyl or phenyl groups. But look at this. Here's one example, a little bit thicker. This functional group is an ether, right? It's an oxygen that has two carbon molecules neighboring it. So that's an ether functional group. This nitrogen is actually by itself. This would be an amine. We didn't really cover amine below. I won't expect you to know it, but just to let you know, if you see just a random nitrogen that's not in an amide bond, that would be an amine. Okay, last up, let's check out penicillin. So penicillin has this structure here, and I definitely see I see three functional groups that we've covered. So I see this one here. We'll start here. This is a carboxylic acid, just like in the aspirin, right? Carbon, double bond, oxygen, OH. So that is your carboxylic acid. Then I see this functional group here, which really I just would like to highlight this nitrogen to the carbon to the oxygen. That's an amide, right? An amide bond. And also here is another amide bond. So we have two amide functional groups and then one carboxylic acid functional group. Okay, so that's just kind of looking at functional groups and how they are, and seeing how they're found in molecules of some medicines that we take almost not every day, but that we've probably taken at some point in our lives.